I think we are live now. I hope my screen is visible as ABC332. Hello everyone. I hope I am audible now and there is no noise echo. Today I would be participating in Atcoder Virtual Beginner Contest 302 as a virtual contest, and along with that I will try to explain my approach probably after I get an AC or something like that. And like probably then we can get started. Uh, any tips to reach specialists soon? Like, to be honest, like the only way to do is to participate in a lot of contests and then solve a lot of problems, like problems which you are not able to solve during the contest. Like if you just solve one or two more problems more than what you were able to solve in the contest, in the long run you would be able to reach whatever level you are targeting. So like there are no shortcuts. Like that's the proven way. Like everyone does it. Like, and probably you will have to also do. Like greedy में दिक्कत होती है. Like the only way to do it is to prove your solutions for the greedy, and like you can look at some YouTube articles like on the exchange argument. Exchange argument works really well to prove the greedy algorithms whether they will work or not. Like what will be the level of contest? Like ABC is Atcoder beginner contest. Like first problem would be one if or else, while the last problem's difficulty would be around due to F or something like that. Like, and I think anyone who is rated less than 1200 on code forces would be able to solve at least three problems in the Atcoder beginner contest because its name is beginner contest as well. Okay, the contest has already started for me. Like I will download the test cases first and open all the problem statements. First problem statement says Atcoder INC sells merchandise through online shops. Akazi has decided to purchase n types of products from there. For each integer I from 1 to n, the ith type of product has price pi and he will buy qi of this. Additionally, he must pay a shipping fees. The shipping fees is 0 yen if the total price of products purchased is s yens or above or k yen otherwise. He will pay the total price of products plus purchase plus the shipping fee. Now calculate how much he will pay. Like it's similar to like how we order on Amazon.com or everything. Like if your order size is more than some unit, you do not pay any shipping fee. Otherwise, you pay a particular shipping fee. And you are also given the number of quantities of a particular product you want to purchase. Basically, like if order size is at least S, you don't pay any fee, otherwise you pay KN. And you are also given the number of different products you will buy, quantity of each of them, and the price of for one unit. And we are asked to print the total amount of the invoice. And if we look at the samples, we are given that we would purchase two types of products and shipping would be 500. But if our order size is at least 2000, we don't have to pay any fee. And here we purchase one product of 1000 yen, like this is 1 into 1000, total 1000, and six products of 100 yen, that would be 600. So because 1600 is less than 2000, we will have to also pay the shipping fee over here. And that's how 2100 is the answer. Like next example is similar, just that we buy one product of 5000 yen as well. In that case, the sum of these would be 6600 and we don't have to pay any shipping fee over here. I will code it once. Here number of products you have, minimum order amount and shipping fee. Now run a if our cost is less than S, looks like all the test cases have passed. Let's read next problems. Glass and mug. Atcoder INC sell glasses and mugs. Takashi has a glass with capacity of G milliliters and a mug with a capacity of M milliliters, where G is less than M we are given. Initially, both the glass and the mugs are empty. After performing the following operation k times, determine how many milliliters of water are in glass and the mug respectively. When the glass is filled with water, that is, glass contains exactly G milliliters of water, discard all the water from the glass. Otherwise, if the mug is empty, fill the mug with water. Otherwise, transfer the water from mug to glass until the mug is empty or the glass is filled with water. Okay, we have two things. One is a mug and other is a glass. Capacity of glass is less than capacity of mug. And we have to do something q times, k times. And everything is in some units. If like and at the last we have to report like how many milliliters of water is present in one of them. And the operation is if glass is water and if glass is full, then just forget that water, like remove it and everything from it. Otherwise, if the mug is empty, fill the mug with water. I think it's assuming like m milliliters of water. And otherwise, transfer the water from mug to glass until one of them is empty. Let's look at the sample ones. Like initially, everything is empty, right? Yeah, initially everything is empty. So like it says the we have to do it five times. Like glass has capacity of 300 and mug has capacity of 500. So like operations would be as follows. First, fill the mug with water. So that glass has 0 milliliters of water and the mug has 500 milliliter of water. Transfer water from mug to glass until the glass is filled. Therefore, the glass will have 300 milliliter of water and mug will have 200 milliliter of water. Discard all the water from glass. Then the glass will have 0 milliliter of water and the mug will have 200 milliliter of water. Transfer the water from mug to glass until the mug is empty. So now the glass will have 200 milliliter of water and mug will have 0 milliliter of water. And fill the mug with water. So the glass will have 200 milliliter of water and the mug will have 500 milliliter of water. And after we have done this 5 times, our glass will have 200 milliliter of water and mug will have 500 milliliter of water. Hence, we should print 200 and 500 separated by a space. Probably we can try to code this one. Let's do it by condition. First is if the glass is filled with water and it contains exactly G milliliter of water, discard everything. So if glass contains exactly G, this is our first condition. Second says otherwise if the mug is empty, fill the mug with water. So if the mug is empty, otherwise transfer water from mug to glass. And it would be minimum of capacity present in glass, like the amount of water glass can take again, and the current water in the mug. So, and at last, once we are done, print everything. Looks like it passes the two samples. Let's submit it once. We are good over here. Let's move to next problem now. So next one is answer with its flavor. You are given Takashi's schedule of n days. You are given Takashi's schedule for n days, a string of length 1 n, which consists of 0, 1 or 2. Specifically for each integer I satisfying 1 to n, character of string is 0. If he has no planned schedule for this day, ith character of string s is 1. If he plans to go out for meal on ith day, ith character of s is 2. If he plans to attend a competitive programming event on ith day. So like there are three things he can do. Either he can remain at home, or he can go eat out something, or he can participate in some contest or something like that. Now we are given Takashi has M plain t-shirts all washed and ready to wear just before the first day. In addition to able to satisfy the following condition, he will buy several Atcoder logo t-shirts. On days he goes out for a meal, he will wear a plain or a logo t-shirt. On the day he attends competitive programming event, he will wear a logo t-shirt. Like he can do anything, he can wear any of the t-shirt when he goes out for a meal. And if he wants to participate in some contest, he should wear Atcoder logo t-shirt. On day with no plans, he will not wear any t-shirt. Also, he will wear all the t-shirt worn at this point. He can wear them again from the next day onwards. Once he wears the t-shirt, he cannot wear it again until he washes. So if he is doing nothing, he will wash all the t-shirts here with him, and he can wear everything again back. It means the minimum number of t-shirts he needs to buy to be able to wear appropriate t-shirts on all the schedules during end days. If he does not need to buy new t-shirt, print zero. Assume that the purchased t-shirts are also washed and ready to use before the first day. Now let's look at a sample also. It says 112.022. If Takashi buys two logo t-shirts, he can wear the t-shirt as follows. Like on the first day, wear a logo t-shirt and go out for a meal. On the second day, wear a plain t-shirt to go out for a meal. On the third day, he wears a logo t-shirt to attend a competitive programming event. On the fourth day, he has no plans. He washes all the t-shirts. This allows him to reuse t-shirts worn on the first, second, and third day. So now he has two competitive programming t-shirt and one plain t-shirt over here, and he can wear them again. On fifth day, he wears a competitive programming event, and on the sixth day, he wears the competitive programming event. If he buys one or fewer logo t-shirt, he cannot use t-shirt to meet the condition no matter hence print. Okay, we are also given like we should always buy Atcoder logo t-shirt, and we are also given the plain t-shirt he has. Like, one idea can be to binary search over here, but we don't really need a binary search. I think like we can also do it on the go. Purchase t-shirt only whenever it's required. That could be the way to go forward. Have we maintained two counters? Logo t-shirt count, which is initially zero. Then was logo shirt count, which is also zero. Was normal shirt count, which is M initially. If he is doing nothing, then he will wash everything. Like he is going for shopping. His first priority would be to wear normal wash shirt. If he can't do this, then he should wear like logo shirt. If there is a washed logo shirt, he should just use it. Otherwise, now he will have to purchase a new shirt and he can immediately wear it. And once everything is done, we can print the number of logo shirts which we needed. Looks like samples have passed. I will just go ahead and submit it. like an AC. I will move to next problem now. Swapping puzzles. You are given two grids A and B, each with H rows and W columns. For each integer I comma j satisfying I less than I between 1 to H and j between 1 to W, let ij denote the cell in ith row and jth column. In a grid A, cell ij contains integer aij and grid B, cell ij denotes integer bij. You will repeat the following operation any number of times, possibly 0, and in each operation you perform one of the following. Consider an integer I satisfying like I between 1 to h minus 1. Swap I and I plus 1th row of the grid A. Choose an integer satisfying I between 1 to w minus 1. Swap I and I plus 1 column in the grid A. So basically, we can either swap two continuous rows in grid A or two continuous columns in grid A. Determine whether it is possible to make grid A identical to grid B by repeating the following operation. If it is possible, print the minimum number of operations required to do so. Grid A is identical to B if and only for all the pair of integers ij satisfying this, the integer written in cell ij is equal to integer written in cell ij of B. Okay, then we are also given that the number of columns is less than 5. Like probably I will move to next problem once. Like, one thing which I can do is I can try all the permutations of columns and all the permutations of rows. Like that would be around 5 factorial into 5 factorial 120, and yeah, that should work. And then we can count the number of inversions on each side to find the minimum rows. Yeah, that should work. We will have to also read it. Okay, I will take some questions after solving this problem, so you can ask them in chat if you want. First, we will check it. We should also check if all the A and B are identical. If this should work. Let's check on this. Okay, looks like samples are passed here. Any questions so far? I can take some questions before moving on to the next problem. Okay, so I will move to the next problem then. Lucky bag. Atcoder INC sells merchandise on its online store. There are n items remaining in the company. The weight of item is WI. Takashi will sell these items as D lucky bags. He wants to minimize the variation of total weights of bag in the items in the lucky bag. Here the variance is defined as like sum of xi is mean of the bag, like normal usual definition. Find the variance of total items weights of in the lucky bags when the items are divided to minimize this value. It is acceptable to have empty lucky bags, in which case total weight of items is in that bag is defined to be zero. But each item must be in exactly one of the D lucky bags. Okay, looks tricky. Okay, like constants are D and less than 15. Okay, it's less than 15. What I'm thinking is like we can also split the definition of variance over here, and we should be able to do something like bit mask over here. Like one way to write variance would be sum of xi square minus the mean value. And wait, the mean is fixed because like we have to put every item in at least one of the bags, right? So all we have to do is minimize the sum of xi squares for this one. Like I'm thinking of using this formula. This is sum of square of weights, average expected average value, and this is sum of weights in each bag. And this is fixed because total weight is fixed and total number of bags are also fixed. So now we can use a bitmask DP, I think, over here. Overall, the time complexity I am thinking of is 15 into 10 to the power 13, and hopefully that will work over here. Yeah, this should work. Although sorting is not required, but you can just total bags left are initially and everything is left initially. Let's also find the weight of all them. My type is just a boolean. Yes, I am solving E right now. If bags left are zero, and if any item is left, then we should return infinity. So it's return zero. If current value has already been computed, return current. Now we can use 3 square, like 3 to the power and for loop for some of our subsets. I pretty much refer this blog whenever I need this. This is a 4 to the power n loop, which will definitely get really. And this is one 3 to the power n loop over here. If no items are left, we can just solve it. We also need weight of items in the current bag. We can pre-compute it as well. This should complete our code for this program. Let's run samples one. Okay, like we have some precision issues. Like first sample looks fine. There is no other sample. Probably let's just submit it then. Like the idea is the mean weight of bags is fixed because total weight is fixed and total number of bags are also fixed. WA looks like got WA on 6 of the test cases. Like the weight of bag is up to 1E8. Okay, like my infinity should be an SQ, I believe. Weight of bags is up to 1E8. There are 15 bags. So 1.5 E6. Yes. Like my infinity should be more than like somehow squares of the total weight of it. Formula for variance of this. Like this is fixed and we have to minimize this, which I am doing using some of our subset DPA algorithm for which works in 3 to the power 50. Okay, WA again, 6 test cases again. Okay, um, okay, like just 2 times infinity overflows. Yeah, 2 times infinity overflows. Let me just generate a test case sample one more time. This should have zero variance. This should also have zero variance by the way. Okay, yeah, variance should be there because the number of nodes are 15 only. Had it been even, it would have been zero. Okay, WA again. It's test cases again. At this point, I am not really sure if it's due to some overflow or some other issue with my code. For now, I will probably move to the next problem and I will look at it later, like why I am getting WA on 5 or 6 tests. Moving to problem F now. Random update query. You are given integer sequence A from 1 to an of length n. We will perform the following operations on A from I equal to 1 to m in this order. Choose an integer between L to R inclusive uniformly at random and denote it as P. Change the value of AP to xi. For the final sequence P after the above procedure, print the expected value modulo something for each of AI. Okay. So for each node, we also need the probability that it gets selected, and anything after selecting that does not impact it. I think we can do it using a segment tree on queries. Like the number of queries are m. Import modulo. Also import segment tree. Like I'm using Atcoder library. Like I have a setup for that as well. Probability that parent should be selected AI by VI. Like the idea is I am building queries and like the ith query is the response. If ith query was selected for a particular node and none of the query after it was selected over here. So I'm denoting it as two pair. Expected value if ith query is selected and like if I am running it on a segment tree then I can also maintain the expected value from L to R. Now I have n queries as well. LR, one based indexing. If I am at L, then I should update query QR. Like, I should make it one based indexing. I should update query with probability that this particular node is not selected is And when I reach R again, I should revert this query. First set 0. Looks like sample does not pass it over here. Let's debug it once. Okay, I think wait. D0 looks fine. Length is 2 1. This should be 1, right? Okay, yeah, R minus L. Three into half plus 1. The answer should be like answer should be 3 by 2 plus 2, 2 by 5. Yeah, like algorithm looks correct. but not really sure why I'm not getting the correct answer. So this should be reversed. Yeah, now this passes sample. Okay, I have around 43 minutes left and two problems to solve. I don't know why my E is getting WA. Yeah, like I will try one more shot at E. Okay, I see a mistake. Okay, that's Like, why is it printing median as negative? Looks like precision is used somewhere. Let's use int 120 again. Okay, I think the issue is over here. And I will have to be careful with int 120. I am hopeful this time it will pass. Yes, got an AC on. You know, I have just 30 minutes remaining and like the problem. Not really sure if I would be able to solve it. There are several balls. Each ball is one of the colors 1 to n, and for each I equal to 1 to n, there are AI balls of color n. Additionally, there are m boxes for each j equal to 1 to m. The jth box can hold up to bj balls in total. Here, for each pair of integers I and j, satisfying I between 1 to n and j between 1 to m, the jth box can hold at max, at most I into j balls of color I. Print the maximum total number of balls that the box m boxes can hold. Okay, N is really small over here. Okay, there is ball level restriction as well. Looks like knapsack. Okay, there are 500 colors, but 5 types of balls. Okay, I should go there. Honestly, I have no idea like how do I approach this problem. So I will probably end my contest now. Like, if there are some questions in the chat, I can take them. Otherwise, I will close it. Okay, so thanks everyone for joining.